Hello, this is Aman Verma, roll number 2101 AI37, going to present over the topic of domain adaptation. So what is domain adaptation and what is the need of it? We will look into the slides. Before that, we will just take an example and see what happens in the case of the machine learning algorithm. Suppose there is a data set which converts the traffic sign signals on the German routes. Now we have trained a model using the data set, and now we want to test the data. Now we have taken the testing data from the Indian routes. So think a minute and we will look ahead. So just start thinking, will it work on the Indian routes? Now we will just go to the next slide and we'll answer it in the few next slide. So here first are the contents what are going to be covered. First we will look at the introduction of the domain adaptation. What is it and why it is needed? Like there are many learning algorithms, so what is the use of it? Now, how it is different from the other learning techniques? Like there are many learning techniques which are very similar to the domain adaptation. They looks just exactly the same domain adaptation, but they are different from it. So they are different from it, we will look over them. Third, we will see what is the categorization of domain adaptation. How the issue of domain adaptation, like the issue that the domain adaptation is solved, how can we categorize further? And at last, we will see the approaches to implement the domain adaptation learning. So in that case, we will see the instance-based technique, feature-based technique, and at last we will see neural network-based or the deep domain-based techniques to solve the deep domain adaptation. So first, let's to come to the introduction part. So what about traditional machine algorithm? We are now talking about the domain adaptation. So why is it needed? So you know what is comes in the machine learning. We have some training data, some testing data. We train a model using the training data and test using the testing data. But we assume the very basic assume of the traditional machine learning algorithm is that they assume that the training data and the testing data comes from the same distribution. So how is it relevant? Like if we are asking questions, 2 plus 2 is 4, it is provided to you. 1 plus 1 is 2, it is provided to you. So if you somebody asks 2 plus 1, you will simply answer 1 plus 2 is 3. So they comes from the same distribution, means the same knowledge you have there and same information you are asking. So it is very easy in that case. But what happens, some data comes which is not very relevant to you. Suppose you have learned 2 plus 2 is equal to 4, but somehow it is asked minus 1 minus 3, what will? The basic answer is minus 4, everyone knows. But if you have the limited knowledge of 2 plus 2 4, how will you answer it? So the traditional machine learning algorithms doesn't always work in the real life. How it will not work? So there can be many instances in that. If you are taking the weather data set and suppose before 30 days that weather was somewhat different and now it is different, so in that case the data sets distribution will be a little different and the model will not be very efficient on the both data sets. Or there can be case when you are taking the data from the different source or location and you are testing on the different location. So in that case it is not always necessary that the traditional machine learning algorithms works. So here comes into the picture what is domain adaptation. So domain adaptation is the field which is used to learn the data set so that it can work on the similar data sets which comes from the different distribution. So if we are speaking in the very easy language, if we are given the information and the other information which is very relevant to it and it is little different from it, so you can take that information from that single model. While what used to happen in the traditional machine learning algorithm, you had to train the another model. But using the technique of the domain adaptation, you can use a single model and test the data which is comes from the different distribution. So it is very efficient. So now what we are talking the start, like if we have German traffic signals data set and we have trained on it. So whether to work on the Indian routes, essentially you got the answer. It will not work now. Because why it will not work? Because the traffic rules and regulations following the European system are very different from the Indian systems. So if the distribution is different, then definitely our model can only learn one distributions or one kind of knowledge. So it will not essentially work on the Indian road systems. So here is the comparison you can say for two different data sets. If they are from different distributions, we have to train two different model you can say, and using the domain adaptation techniques, you can just learn on the one data set and train it and using all the other target domain, using the domain adaptation techniques. How we will do? We will look in the approaches section. So here you can see that these are two data sets for digit recognizer and they are somewhat similar. So traditional machine learning algorithm can easily recognize them. But just look at them. Here are cars coming into the road and here are cars coming out from the our camera point of view. So these are little different. So with our traditional machine learning model will work efficiently? Definitely not. It will work some time or can be not very accurate. So in that case, we can use a domain adaptation. So now we will talk how it is different from other learnings. So first we will know about the transfer learning. What is transfer learning? Transfer learning is a algorithm which we use, like we are learning some task and we are using the information gained from that task to the other task. For example, you can see if you are learning the calculus from one course and using this information in the statistics or the probability or the algebra course, that it's called transfer learning. You are the extracting information one model or one data set and using in the other task. So that is called transfer learning. So it domain adaptation, because it is also uses two data sets which are little different but are very similar. So in that case, domain adaptation says that it is a special case of transfer learning. Yeah, domain adaptation is a special case where it assumes that the data sets are from different distribution. Now come to the second, that is semi-supervised learning. When we use the supervised learning, when we have some labels given, and when we use the unsupervised learning, when we have not labels. But when we use a semi-supervised learning, when we are given some labels but that are not enough to train our model, so in that case we use the semi-supervised learning. So it is similar to the domain adaptation where the labels can be different in two data sets. So that is also a case of domain adaptation. But domain adaptation also assumes that they are from should be from different distributions, which is not the case of the semi-supervised learning. So in that sense, they are different. And third is multitask learning. So what is multitask learning? Like you are given a single model and you are learning some task. Means you are learning some properties of the data sets parallelly or simultaneously, you can say. For example, you are given a large number of array. So in that case, you are recognizing each number and then summing up it. So there are two stars involved and you are doing it simultaneously. So that is called multitask learning. So domain adaptation, how is different from that? Domain adaptation works sequentially. Like first it will work on one training data set and it will work on the other data set. So it is different from multitask learning. So these three learnings are very similar to the domain adaptation, but little different from it. Here you can see that the flow chart of the transfer learning, which is when we see the main learning algorithm under which they are categorized. You can see that the multitask learning, domain adaptation, unsupervised learning. So these are the parts of the transfer learning and a special case of. So domain adaptation is also a special case of the transfer learning. So now comes to the categorization of domain adaptation. On the what basis we will categorize the domain adaptation? Now we have realized that how to use the domain adaptation when the testing data and the training data are different, but they are similar kinds of they have the similar kinds of properties, but they have follow the different distributions. So they can be different under two cases, like when the labels are different or when the distributions of their features or the labels are different. So first just see the notations we use. So here are very traditional notations we use. So that are used in the machine learnings, X and Y, that is input and output. And the probability, joint probability, as you can see, we can use simple the conditional probability for bonus. And it can be classification where we are if using binary, then -1 +1. Or if we multiclass, then we can use the 1 to k. And feature space is a real data dimension. So what we assume in the machine learning traditionals, like we have to minimize the risk. So we will just minimize the risk first on the source domain that is given here, like what we have predicted and what is actual, and we take its expectation and try to minimize it. Now we assume that it will also get minimized on the target domain. So using simple algebra, we assume that it will also work on the target domain. And if we minimize the risk on the training data, it will also be minimized on the testing data. So let's first talk about the categories that are divided on the basis of the category. What is category here? Like if the labels are different in the source domain and target domain. So first let's talk about the closed set domain adaptation. What is the closed set? If we have given the source domain and the target domain, and the labels or the classes you can see are same, but their distributions are different, means because there still exist probability distribution which are different, but the classes are same. In that case it is called the closed set domain adaptation. You can say, I give example, like you are asked x plus y, and means you are simple given an algebraical problem of x plus y. Now you are asked a very tricky problem of similar algebra. The thing you have taught there, the thing is asked, but it's very tricky, so that the distribution is little different, so it can be categorized under the closed set domain adaptation. What is open set domain adaptation? Open set domain adaptation, like the question is asked which are not you answered, but it is come to unknown part, like it is covered from the unknown part, so that is coming from open set domain adaptation. If the target domain contains some classes which are not in the source domain, so that is a open set domain adaptation. And what is a partial domain adaptation? Partial domain adaptation comes when the target domain has some subset of source domain. And universal domain adaptation simply assumes that it doesn't require the prior knowledge of the target domain. Now, these are the pictorial representation where we have discussed that the closed set has have the same classes, and partial has a subset, and open has some unknown from the source domain. And universal requires no prior knowledge. Now we will just look at the domain gap. What is a domain shift? Domain shift is simply changing the distribution of the data. So how it can be changed? It can be changed the prior shift, like if the features or the probabilities of the features given in the data set in the training section and in the testing section are not same. So that can be categorized in the prior shift. After that, the covariate shift. It is very important because most of the domain adaptation techniques are used to solve it. What it says, like domain adaptation, like covariate shift says, like if we have the marginal distributions differ, like conditional distributions you have seen, but the marginal distributions are different, then it is called the covariate shift. And most of the domain adaptation techniques try to solve them. And what is the concept shift? Concept shift is like the given the prior information or the marginal distributions are same, but the conditional probability are not different. So when the conditional distributions are different, we can use the concept shift. So here we will see just it is, suppose this is a source data, and now first we will look at a concept shift. Concept shift, what we have seen, that the conditional distribution should be different. So here you can see all the green are here and the red one are here. So here the conditional distributions are different, so it is called the behavioral change or the concept shift. Now it is a covariate shift which is used most widely. So here you can see here are green, but their distributions are changed. So that is called covariate shift. And the probability change, like here you can see there are more number of green balls, but there are less number of. So the probability change, and this is called the probability shift. Now what are the approaches for to solve or implement the domain adaptation? First, we will see that there can be categorized, or can say there are two types of adaptation techniques to solve. First is shallow methods, or the second is a deep methods. Like if you are using a neural network or the deep learning, that can be categorized into the deep architectures, or you are simply following any method, optimization methods. So that is called the shallow methods. So under shallow methods, instance based or the feature based techniques are used. So here you can see that the domain adaptation techniques are categorized into the feature based and instance based, under which they are categorized shallow domain adaptation. And the third one is the deep domain based architecture that uses the neural networks and the deep learnings autoencoders. So the basic idea of implementing the domain adaptation is that minimizing the discrepancy between source domain and the target domain. So there are some measure of them, like how can we know that we are minimizing it? What are the way to quantify it? So under that we can use a maximum mean discrepancy and KL divergence and contract to domain discrepancy method. So these are the way to quantify the difference in the distribution between the testing data and the training data. So these three methods, what we are talking about, the instance based, feature based, and the deep domain, uses different techniques to minimize these parameters. So we will look upon them. First one is the instance-based domain adaptation. So what is the instance-based domain adaptation? What is instance? We can simply say instance-based adaptation is like making the similar data sets. So when we are making the similar data sets, we assume that their distribution will also be similar further. And in this case, the main problem which is solved is the covariate shift. We use here the weighting parameter. Weight parameter, we use the reweighting factor, which is the target domain probability upon the source domain probability of the feature X, of the instance X, and we just scale them, and we then convert into the new, you can say, data instances, and upon them we train the model and learn them. So that is called the instance based adaptation. So next one is a feature-based adaptation. Feature-based adaptation is very important because unlike the instance-based adaptation, here we try to make the similar features. Like first we can remove some invariant features or the irrelevant features and see those features which are relevant for the both training data and the testing data, and see what are similar between them. Suppose, let's say an example. Suppose we have a data set of the text view of restaurant from two different cities. If they are two different cities, essentially they are from the different distributions. So how can it be solved? It can be solved the feature based adaptation. How can we solve? Like one way to use the feature based adaptation to address this problem is to the align feature representation of the source and target data. So we have to align the features, like we have to make the features similar to in both the data sets, like from two different cities, make the features similar and just then train the model. So under this feature-based adaptation, there are further categories like subspace methods, transformation method, construction-based. So you can any of them to solve this. So first, let's go to subspace method. So what happens in the subspace method? We used to find a common subspace between the training data and the testing data. How can we find it? Like in the feature-based adaptation, what are we doing? We are extracting the relevant feature from the both the testing data and the training data. So how can we find the common subspace? Using the common subspace, we are extracting the similar features. So how can we use? We can use a principal component analysis or the canonical correlation analysis. So using that, we can minimize the discrepancy between them. So suppose you have two images of cars from two different countries, and now using the about techniques PC or CCA, you can find some relevant information, relevant features from the both data sets, and then can train the model. So it is very useful in the NLP techniques or the computer vision techniques and speech recognition, where the instant based adaptation will not work very effectively. Now we will look at the transformation based. So what we do in the transformation based, we just transform the features into the features which are very relevant to target domain. So if you have given some features of the source domains, we will transform simply into the mm, mm, similar features to the target domain. Under which technique we can use the linear discriminant analysis or the transfer component analysis or joint domain adaptation. These are techniques which we can use to transform the features. And the third one is the reconstruction based. In first one we saw that we are extracting the common space. In the second we see that we are here using the transformation. And here and here we are taking the deep domain adaptation. So what is mean by deep domain adaptation? When we are using some neural network or the deep learning, in that case we call it the deep domain adaptation. So what is that? It tries to train the model without any prior knowledge. Yeah, it's aims to train the model without any prior knowledge, so that in the training data and the testing data should it minimize the discrepancy between them. It can further be categorized into the discrepancy based or the reconstruction based, as we saw in the previous feature based adaptation. And third was the adversarial based adaptation. But as we know that deep learning uses a lot of data, so it is computationally expensive in comparison to the previous techniques. So let's talk about first the discrepancy based domain adaptation. Yeah, this is simply just the name suggests is try to minimize the discrepancy between the source and target domains. It also uses a similar parameters as we have seen earlier. The maximum mean discrepancy and the correlation alignment and Western distance are the parameters which are used to quantify the distribution difference. So deep domain adaptation in the that category discrepancy based, like it tries to extract the two, it's just changed two things. First one is the feature extractor and second is the classifier. So was that the first feature classifier that using the neural networks, it first extracts the features and learn the parameters, and second it classifies that the data set into classifier it trained. So in that case we are using the training data and testing data to make it similar. Now coming to the reconstruction based, as we have also seen in the feature based data domain adaptation, that it reconstruct the feature. So now we are reconstructing the feature using the neural networks or the deep learning. So that is why it is called the reconstruction based deep domain adaptation. Here we can use the auto encoder and reduce the invariant features, and we can also use the transfer learning. Now we are when we are reconstructing the training data or the testing data, the parameters should be learned. Yeah, so we are just first using the neural network or the deep learning. We first learn the parameters of the encoders, and then we reconstruct the domains of training data and the testing data. And after that, we try to minimize the difference between the distribution difference between them. And at last we have the adversarial based. Here the main comes like a generator and a discriminator. These are the tools we are used to train in the adversarial learning. So what the generator does, it try to mimic the data from the given data, and the discriminator does, it try to discriminate the data it has generated earlier. Yeah, so first it try to mimic the data from given data, and the discriminator comes and it tries to discriminate the data. So in that case it tries to minimize the discrepancy between the training data and the testing data, because we have already trained the in the adversarial learning about it. So these are the techniques we are used to reduce the discrepancy between the training data and the testing data. So just we look the quick comparison between them. So here are the instance where we just try to reconstruct or try to change the data instances, and here in the feature based we try to change the features or the extracted the features and constructed them, and in the deep domain we can just train these things as we do in the feature and instance using the neural network or the deep domain or the deep learning. So that part is from the deep domain. So how can we do in the instance where how we did using like in weighting or the self-training, we uses the scaling feature by multiplying with the re-weighting vector, and in the feature based we uses the correlation alignment or the KL divergence parameters to minimize it, and in the deep domain we use the autoencoders or adversarial networks. So what are the first disadvantages? Because already we have talked about the advantages of it. So instance based, because it can't be very effective, that's why we are used to need of feature based adaptation, as we can see computer vision or the speech recognition. And the deep domain is that it can be computationally very expensive, and examples we have already talked about, like when to use instance based, when we use feature based, and when we use the deep domain. So that's all for the domain adaptation that we are talking about. Now we have learned that the domain adaptation is a technique where we are just try to minimize the discrepancy between the source domain and the target domain. If we have successfully reduced the discrepancy, then we can train a model and run the testing data, and our accuracy will be much better than the model which has used which is trained using the traditional machine learning algorithms. So that's all for this. Thank you. It is presented by me, then Aman Verma.